Good day, viewers. Welcome to another mathematics presentation. This is your presenter, Mr. Mleng. So during this presentation, we are going to look at the topic circle theorems, and under this topic, we are going to do question and answer. So this is part 1 of the video. So more videos will be uploaded under the same topic. So let us look at our first question. This is our first question right here. Calculate with reasons the sizes of angle B and angle C. So we have been given a circle right here. So this circle is having a triangle, as you can see. So we have the angle marked B and the angle marked C. So we are going to start with the first question where they want us to find the angle B. So how do we find the angle on B right here? So to find the angle on B, we need to use one of the theorems and we need to explain. So when you look at this line, which is passing through the center O, this line is called a diameter. So this diameter is cutting the circle into two equal parts, that is, into a semicircle. So an angle in a semicircle is a right angle, okay? That is the theorem. An angle in a semicircle is a what? A right angle. So when you look at this diameter, okay, then there is another chord being drawn there and there is another chord being drawn here. So the angle which will be at B right here is going to be a right angle, which is a 90 degrees. So angle B is equal to a 90 degrees. This is our answer. So here we are going to have a 90 degrees. So we have answered. The reason is simple. An angle in a semicircle is a 90 degrees, or a right angle right there. So how can we now find angle C? So to find angle C, it's very easy. Okay, to find the angle on C is very easy, because here on B we have a 90 and here we have a 55 degrees, and this is a triangle. So sum of angles in a triangle adds up to 180. So if you add angle on C plus the angle on B and the angle 55 should be equal to 180. Okay, so in this case, to find the angle on C, we are just going to say angle C equal to, we will get the 180 degrees minus, so we are going to add the 90 degrees plus the 55 degrees. Okay, so from there we say angle C equal to 180 degrees minus, so when you add these two angles, when you add a 90 degrees plus a 55 degrees, it's going to give you 145. So you can now say, therefore, the final answer, you just subtract, you say angle C equal to 180 minus 145, and this will give us a 35. So this means that on C the angle was a 35. So here the answer is a 35 degrees. So this is how we can find the angle B and the angle C. So we are done answering our question 1. Let us now move on to our question 2. So this is our question 2 right here. So under this question 2, they have asked us to calculate an angle BCT. BCT, the angle which will be right here on C. So how can we find the angle on C? So to find the angle which will be right here on C, first thing, we can take a look at the angle or triangle ABC. So ABT. Okay, so this triangle right here, this is an isosceles triangle because of these marks that are given. So it means that the angle which is here and the angle which is there are the same. Okay, these are same angles. And the ABCT, this is a cyclic quadrilateral. Okay, so in order for us to find the angle on C, okay, we need to find the angle on A right here. So this angle on A, we are going now to say opposite angles in a cyclic quadrilateral adds up to 180. Okay, so in order for us to find the angle on A, we need to find an angle on B right here. So how do we find an angle on B? This is the alternate segment. So the angle B and this angle right here on angle ATP, they are equal. So we are saying angle ATP, this angle right here, is equal to angle ABT. So the angle which is right here, the angle which is right here on T is equal to the angle on B. So even on B are going to have a 76 degrees. Why? Angles in the alternate what segment. So this angle and this angle are the same. So if you have a 76 here, and I've said the angle on A and the angle on T, they are the same. So to find the angle on A, we are going to consider the sum of angles in a triangle. So if we say to find angle BAT, okay, to find angle BAT, you are going to say 180 degrees minus a 76 degrees, then divided by 2. Why are we dividing by 2? Because we know that the angle on A and the angle on T are the same. Okay, so we are going to say angle BAT equal to, so when we get now 180 minus a 76, this will give us 104 degrees. So this will be 104 degrees divided by what? By 2. So angle BAT will be equal to, so you just need to divide by 2, of which 2 into 104, this will give us a 52 degrees. Okay, a 52 degrees. So this tells us that the angle which is right here is a 52 degrees. Okay, here we have a 52 degrees. Even right here we are going to have a 52 degrees. So this now makes it easier to find the angle on what? On C right here. Okay, all right. So now to find the angle BCT, so to find the angle BCT, okay, BCT, the angle on C. So we have an angle right here on A. So we'll consider opposite angles in a cyclic quadrilateral adds up to 180. Okay, opposite angles in a cyclic quadrilateral adds up to 180. So if we say angle BCT plus angle BAT, this should give us 180 degrees. So from here we are going to say angle BCT equal to, so you get 180 degrees minus angle BAT, it's a 52 degrees. So therefore when we subtract 180 minus a 52 degrees, this will give us what? 128. So here we are going to have 128 degrees. So meaning that the angle that was on C was a 128. So opposite angles in a cyclic quadrilateral adds up to 180. This is the property that we have used. So we have answered our question 2 right there, which is very easy. Let us now look at our question 3. Alright, so we've now come to our question 3 right here. Find angle RPT. RPT. So they want an angle right here on P. So how do we find angle RPT? So to find the angle RPT, we understand that angle RPT is alternate to angle RQP, meaning that alternate angles in the same segment. So the angle on Q on the RQP and the RPT is equal. Okay, so I've said the angle RPT is equal to angle RQP. So first thing, we need to find an angle right here on Q. So how do we find an angle on Q? When you look at the triangle that is inside, you can see that this is an isosceles triangle, meaning that the angle which is on Q is also equal to the angle on P, okay, on RPQ. So we need to find the angle inside here. So we are going to consider the sum of angles in a triangle. Okay, so when we add 80 plus the angle which is on Q and the angle which is on P should give us 180. So the way we are going to find first, we find the angle RQP. So to find angle RQP, we are just going to say 180 degrees minus 80 degrees. Then we divide by what? By 2, because the angle on Q and the angle on P are the same. So therefore we say angle RQP is equal to, so 180 minus 80, this will give us 100 degrees divided by 2. So 2 into 100, this will give us a 50 degrees. So this means that on Q right here, the angle is a 50 degrees. Even here, the angle is a 50 degrees, such that if you add 80 plus 50 plus 50 to give us 180. So remember, the question wants us to find the angle RPT, the angle on T right here. So I did mention that angle RPT is equal to angle RQP. So this angle on Q is an angle in the alternate segment with RPT. So the angle on Q is equal to the angle on RPT. So if there we have a 50, even here we have a 50 degrees. So that is the answer. We've come to the end of our session. Thank you so much, everybody, for having time to view this content. This has been your presenter, Mr. Mlenga. Bye-bye.